In order to solve this problem, we use Newton's law of cooling. For this problem, it is big T of little t, the temperature at a given time, which is equal to TA plus TO minus TA times e to the negative k times t. In this case, big T is temperature, TA is the ambient temperature, which is identified as the temperature of the room, TO is the temperature of the object, being Mr. Fies' body, K being the decay coefficient, also known as the constant, and finally, little t equaling time. For this problem, the first step to solve is to find the value of K. First, determine the value attached to each part, which goes as follows. Big T of little t is 75 degrees because at 8 p.m. the temperature of the body is 75 degrees. TA is 70 as the room is kept at a constant 70 degrees. TO is 80 degrees because that is the temperature at which the body was found. We are solving for K, so currently it is lost in the sauce, and little t is 0.5, as the time lapse between 7:30 and 8 p.m. is 30 minutes, which is 0.5 of an hour. The first step is to plug all known values into the equation and then solve what is in the parentheses. Simplifying the equation to 75 equals 70 plus 10 times e to the negative k times 0.5. Then subtract 70 from both sides, which gives you 5 equals 10 times e to the negative k times 0.5. The next step is to divide both sides by 10 in order to isolate the e, and then to get rid of said e, I will take the natural log of both sides. By using the calculator to take the natural log of both sides, we are now left with negative k times 0.5. In order to get k completely by itself, you must divide both sides by a negative 0.5, or 1/2. K, who is no longer lost in the sauce, is equal to 1.3862943661. We have now found K, which is the decay coefficient or the constant at which the temperature of Mr. Fies' body is dropping. Now we must determine and discuss the approximate time elapsed to the nearest tenth of an hour from time of death to discovery. For this part, big T of little t is 80 degrees, as the body at the time of discovery is 80 degrees. The TA is still 70 degrees, as the room remains at a constant 70 degrees. TO is at 98.6 because the human body on average is 98.6 degrees. K, as discovered in the previous step, is 1.3862943661. Now we are looking for little t, which in this case is the time between which he was killed and when he was discovered. Similarly to last time, we need to plug all known values into their respective spots in the equation. Solve within the parentheses first, and then subtract 70 from both sides, lastly dividing both sides by 28.6. Then to get rid of the e, we have to take the natural log of both sides, and now we are left to divide by 1.3862943661 to get t by itself. This means that the time of death to time of discovery is rounded to the nearest tenths place, 0.8 of an hour, calculated as about 48 minutes. To determine the approximate time of death, I subtracted 48 minutes, the time figured out from the previous step, from 7 hours and 30 minutes, the time of discovery, to find that Mr. Fies was in fact murdered at 6:42 p.m.